In question 1.4, we are demonstrating a DNS spoofing attack. Normally, when a user wants to visit a website like www.example.com, their computer sends a DNS query to the local DNS server asking for IP address of that website. The DNS server then replies with the correct IP address. In this attack, the attacker's machine sits on the same network and constantly sniffs for these DNA query messages. As soon as it detects one, it sends a fake DNS response to the victim before the real DNS response arrives. This fake response has a malicious IP address. In our case, the fake IP address is 7.7.2.4, which is the last four digits of my student number. The victim's machine accepts this fake response and connects it to the wrong IP address without knowing it was tricked. So we have four machines running in our Docker: the victim, the local DNS server, the attacker's machine, and the attacker's name server. First, what we'll do is we'll navigate to the lab setup folder, and then we can continue doing with our question. So as we can see, these are the dns.py and docker yml. What we'll do is like now we'll verify if all the Docker terminals containers are running up. So as we can see, the Docker containers are running. We can also see that this is the local DNS server, the attacker NS, the seed attacker, and the seed router. What I'll do is like I'll show you my complete DNS spoof.py script. In this script, as we can see here, we have a packet sniffer at the interface like BR1DD566B for UDP. Inside the function, we also flip the source and destination's address, so the response goes back to the victim. uh, After, let's execute it and we will continue explaining. Dot py. Oh, sorry. So as you can see, the packet sniffer has identified it. Now we'll copy the script into the attacker Docker container. The successfully copied message. Now I'll open, a Docker terminal inside the attacker container. Now I'll run the DNS spoof script. The attacker machine is now actively listening on the network for any DNS queries. After running the attacker script, we'll open a new terminal and then run the victim's machine. But let's go for the attacker's machine right now. Now what we'll do, I'll open the second terminal to simulate the victim's machine. And now I'll log into the victim's machine. the user, you might have confused it, like where do you get this 10.9.5? It is right here. Let me scroll up. Yeah, user, seed user 10.9.0.5. Sorry, 0.5 bin slash bash. Oh, sorry, my bad. Slash bin slash bash. The victim, as we know in this case, is the user with 10.9.0.5. Will now query for, let's say, example.com, as we have written a script for that. In a normal scenario without any attack, uh, it should return the real IP address. I don't know what it is, but like the real IP address. Let's see what happens in the attacker's machine after we dig here. Example.com. Oh, as we can see, www.result.7.7.2.4 our fake IP address. The DNS spoofing attack was successful. The flag set is AA, meaning the response is come from the authoritative server, making it look like it is completely, authenticate, like original. The TTL is the query ID machine. The query ID matches between the victim's request and a spoof response. This is why the victim is accepted. Let's close this. Switching back to the attacker terminal, we can see every intercepted query was being logged, showing traffic between 10.9.0.5 and the DNS server, which is 7.7.2.4. This is per query attack. Every time the victim sends a DNS query, the attacker must send a new spoofed response. The, the effect, of course, is temporary, only lasts for one query at a time. This is the key difference between like the DNS cache uh, poisoning, which will demonstrate in like question 1.5. But mm, this is all. Also, yeah, as I said, like the response is coming from like authoritative, which makes it look like it is completely legitimate. That's all for question 1.4. We'll see you at question 1.5. Thank you so much.